Assalamualaikum and hi, my name is Amirul Farhan bin Azman and I am from class 4 Bestari, and today I am going to present my work, which is Kepler's Law. In Kepler's Law, there are three laws. The first one is Kepler's first law, the second one is Kepler's second law, and the last one is Kepler's third law. Let's proceed to the first one, which is Kepler's first law. Kepler's first law is all planets move in elliptical orbits with the Sun at one focus. We can call it as law of orbits. The planets in the solar system have elliptical shaped orbits. The major axis is longer than the minor axis. Most orbits of the planets in the solar system have major axis and minor axis of almost the same length. As such, the shape of the elliptical orbit of the planets in the solar system is almost round. Planets can be assumed to make circular motion around the Sun. The radius of orbit is the average value of the distance between the planet and the Sun. The next one is Kepler's second law. Kepler's second law is a line that connects a planet to the Sun sweep up equal area in equal times. We can call it as law of area. If a planet takes the same amount of time to move from A to B and from C to D, the area of AFB is the same as the area of CFD. The distance AB is longer than distance CD. This means the planet is moving at a higher linear speed from A to B than from C to D. The last one is Kepler's third law. Kepler's third law is the square of the orbital period of any planet is directly proportional to the cube of the radius of its orbit. We can call it as law of periods. A planet which orbits with a larger radius has a longer orbital period. As such, planets which are further from the Sun take a longer time to complete one orbit around the Sun. And now, how are Kepler's laws important to astronomy? Kepler's laws describe how a celestial body behaves when it orbits something massive. Kepler's laws describe how planets orbit the Sun. They can also be used to describe how moons orbit around a planet. But they do not just apply to our solar system, so they can be used to describe the orbit of any exoplanet around any star. With some modification, they can be used to describe how binary stars orbit around each other, how stars orbit a black hole, or how a white dwarf orbits around a neutron star. They can also be used to describe how gas disks orbit around a star or black hole. That's all from me. I'm Amirul Farhan bin Azman, and bye. Thanks.